here is Michael Pulin. Today I represent you the final part of the pattern Distributed Transaction for Microservices. It is named Implementation Tips. First of all, let us list the most important implementation aspects. I've calculated them as 8, and they last from scope to the transaction agent, orchestrator, bootstrap, orchestrator and supplemental relationship, interaction and sub-transactions. The scope of transaction is usually covers several microservices or services. It can work inside an application or across application and across applications in different departments. Cross-organization and domain boundaries also important for the scope of the transaction, and transaction always work with local consistent data, while overall state of the transaction may be eventually consistent because microservices can belong to different segments of the network. Transaction agent is an entity which triggers the transaction. It may be API call, it may be event push or event pull mechanisms, but they're always an entity which acts and either sends the API call or fires events. Each distributed transaction as well as each of its instances have a unique ID. We will see later on why it's so important, but each running transaction process can be uniquely identified for management, for debugging, for improvement purposes. Transaction designer should be aware of the transaction agent and vice versa. So the entity which starts the transaction is called transaction agent, and knowledge about this microservice is very important because it defines how the transaction orchestrator can be called. Special case is about event pooling. Orchestrator must know all event pulls for each supplemental microservices using in the transaction, because this is the way how the orchestrator can engage supplemental microservices. Orchestrator also must know about the changes in the event pooling of supplemental microservices, because if they changed being under independent ownership, the orchestrator will not be able to engage the microservice and the transaction crashes. Special access control has to be defined for each polling storage or each polling mechanism, because ownership of that mechanism is not clear who owns it, the orchestrator or the supplemental microservice. It always is the case of the particular application implementation. If the communication with orchestrator must go through the polling, orchestrator should be implemented in tandem pattern, which we described earlier in this series of presentations. While event pooling is okay to be used in the distributed transaction, it's not really recommended because it's difficult to debug and to control due to unclear ownership of the event pooling storages. Transaction steps usually include 9 steps. They are defining the business goal and transaction logic first of all, and logic divided into the steps. We should not start with microservice implementation of the steps. They are the last things we have to take care of. We have to identify the business domains crossed by the transaction and its individual steps, identify step execution context, that means technical, other applications, other microservices, and business like regulations and rules applied to each step of the transaction if it's needed. We have to identify the transaction agent to be sure that transaction can be triggered, and then only then define the orchestrator and its connectivity method, that means transaction manager. Then we have to identify connectivity for each supplemental microservice in their design. And the orchestrator should be aware about those connectivities. Design error handling is the must-have thing for each step, and in many cases the rainy day is more important to go through than through the sunny day. Define orchestrator's data storage for each state is very important because orchestrator is a stateful service. Orchestrator bootstrap actually needed only for the case of pull-based orchestration connectivity, because the push-based orchestrator connectivity actually triggers the orchestrator when it is called or by the event fired for its trigger. The transaction state is always persisted for orchestrator, as well as all changes in the state are persisted, and all state change events are specially logged for the audit and management purposes. The state store may be shared between different transactions. This is the place where the unique identifiers of the transaction and their instances play one of the major roles. Relationship between orchestrator and supplemental microservices, and particularly communication between them, follow the following rules. Orchestrator can pick up any suitable microservice, not necessarily predefined during the design time, if that microservice provides the same type of interface required by orchestrator, as well as functionality and outcomes. This is a backup solution if the chosen microservices failed and orchestrator has to decide how to work forward. Any microservice may participate in multiple transactions simultaneously. That means that microservice has to be very good in concurrent requests handling. Orchestrator should be able to use those communication types that the supplemental microservices use. If there are different types for the same transaction, orchestrator has to be aware about all of them. Sub-transactions usually exist for relatively complex transactions, and they act the same way as sub-processes for the processes. Sub-transactions are found or may be uncovered through the decomposition of each transaction step. There may be one sub-transaction, may be multiple sub-transactions, may be sub-transaction of sub-transaction. So altogether they created a layered structure, where in each layer we can find a transaction steps with transaction agent and all mechanisms specific for the transactions. The lowest level represents the transactions with no sub-transactions. The higher level we going up in this decomposition, we find that the higher level of transaction or sub-transaction receive the inputs from the lower level sub-transaction. This is the major element set of the transactions across microservices, and in conclusion we can say that distributed transaction over microservices can meet business needs, and it's a very important mechanism for implementation business tasks. Distributed transaction may be robust or may not, depending on the consistency of the data required, but in major case, in global case, they must be robust, and this robustness provided by runtime failover of microservices. The distributed transaction require professional design and implementation of already existing microservices. So orchestrator and transactions are built after microservices that will be used in the transaction already created and deployed. Thank you. That's all what I would like to tell about that pattern. Please visit my website, which is on the title of the presentation, and there will be much more information you might need to implement distributed transaction. Thank you very much and have a good day.